Hi there. This is actually not my talk. This is Geoff Huston's talk. Susan couldn't find anyone that looked more like Geoff Huston than me, I guess, at Nanog, so here we go. His accent's cooler. But let's see, power forward. So this is a BGP AS address space sky is not falling talk, is the upshot. But Geoff has given this a couple of other places, but I don't think Nanog. So the problem is that, you know, you have a 16-bit field. Everybody's familiar with this problem. It's been mentioned before. 64,000 available ASs, and half of them are used up. So when are we, like, going to run out of space? So this talk is a series of different metrics for analyzing when the sky is really going to fall. You know about the internet draft. It's at least a year old. That's going to essentially expand this to 32 bits. So that's going to be a long-term solution, but we want to know when we actually have to start testing various transition plans and implementations, come up with the AS registry, and start putting these objects in BGP. So again, Geoff's goal of this talk is to find out when we are a safe margin away from running out of space. Like he picks 3 years as a reasonable testing deployment time. Okay, so how do we decide when we're 3 years away from running out of space? Geoff picks 3 metrics: growth of the number of announced ASs in the BGP routing table, the rate at which AS number blocks are passed from IANA to the regional registries, and the rate at which these registries then undertake assignments of ASs to the local registries and end users. So 3 different metrics, projections of the data, comparison of the results. First, BGP routing table. There's our common graph that we're all very familiar with the end of the internet bubble noticed at the inflection point there. And then if you, can you read the bottom graph? So back here it's 1996 to now, and then this projects it. So half the graph is now the existing data, and the right side is projection. Both, like all internet data, you can pick an exponential or linear projection depending on how long a view you take. Exponentials in the red, linears in the green. Differences with exponential running out or hitting the wall up here at June 2008.
If you look for the slides for this talk, they weren't there, they're there now. So you can see these charts.
If animation or running through them this fast isn't going to work for you. All right. Right, so real data in the blue, exponential projection red, linear green. A first metric. Second metric, how are these blocks being allocated from IANA? So now you have a step function because they're allocated in chunks to the different regional registries. Again, 1990 to 2003 data, and then projecting this with both exponential and linear curves ends you up with a drop dead date of somewhere between 2007 and 2011. Last metric, registry assignments, taking the 3 main registries and the number of ASs that are actually assigned to end users or local registries. Real data, projection. Exponential linear between 2008 and 2013. Okay, put them all together. like all important scientific questions of our time, it's just a matter of which hallucination you choose here. So we have something between 2007 and 2013. Now, he does some more interesting data here. He looks at the differences between what the registries have available. So the green data here is, the green line, neon green, is because they're allocated in chunks. So those are the amount of available floating address space that the regional registries have to allocate. It hovers around 5,000 because once they go under 5,000, they get more from IANA. Now, because of that, there's sort of a number that are allocated but not announced. So Geoff's interested in finding out which ASs are actually been allocated over the years and never actually show up in the BGP routing table. The implication here is maybe we could reclaim some of this unused space if we're to extend our duration of survival of the current space. So he finds 10,000 AS numbers, about 40% of those assigned are not even announced. And he wants to find out, is it stuff that's old, that's falling into disuse? Is it recent ones that aren't being used, they're being hoarded and not used? So data, real data, again, 96 to 2003 of announced versus unannounced ASs. Ratio is that, ratio of unannounced to announced. It's been dropping over the years, then it had a recent uptick from 60 to about 70%. That's unclear whether it's a trend we can count on in the future, but here's the projection of unannounced to announced. Going too fast for anyone? I can't hear that. Oh, good. Y-axis is ratio here. The bottom is 0.6. The top is 2.1. The top point up, I guess I should. The top point up there. Bottom down here is 0.6. Okay, by date of assignment, this is blue. Oh, and again, the x-axis goes from 1990 up to 2003, January 2003. Y-axis is number of announced versus unannounced per month. So there is definitely a trend of recent ones being unannounced, a lot of unannounced ones from recent assignments. So then he does this interesting graph, which is the entire AS number space on a kind of pipelined on the x-axis. So it goes from AS1 down here up to the final AS that's been allocated. And the blue is announced, red means not announced, green is unassigned, which means it was either reserved and has not been assigned or it's been reclaimed. So you actually see a little bit of reclamation going on. Things are being returned, but not significantly. I think I just said what was in this slide. Observations, highest. Yeah, lower AS numbers have the highest unannounced to announced ratio, which implies sort of that trying to reclaim ASs in this space is potentially useful. Recent assignments show a 60% announcement utilization ratio for AS numbers. Part of that is the way that they're allocated to local registries, but also there's a disincentive to return something if you're not going to use it immediately. Return an AS number. Okay, now he does the projections of like worst case scenarios in terms of BGP table growth. So the BGP, here's the blue line in the middle. If you were to recover, I'm sorry, what's seen in the BGP table. And the red line is unrouted ASs, green is unassigned. Oh, I'm sorry. So this is if you're trying to recover ASs, so it assumes that an unannounced to announced ratio of ASs that are assigned is something like closer to 0.6 than it is to 0.7, which is where it stands right now. So that's if you do get recovery, you end up lasting until you're at 2011. And if you don't get recovery, you get taken to 2009 with the current space. Upshot of this, available AS number pool will exhaust between 2009 and 2011 if current AS usage trends continue. 2009 if you don't even try to reclaim stuff. 2011 if you get some back. And that's it. You're missing a slide on here which says there's no reason to panic right now. But that's on probably on the one that's on your laptops. Questions? No huge surprises here. Thank you very much.